In the previous video, we learnt about transpose, correct? Where rows become column, column become rows. Let's solve few problems based on that. Alright, look at the first one. If A is equal to this much, B is equal to this much. You know it's a 3 cross 3 matrix. Verify that A plus B whole transpose is A transpose plus B transpose, and similarly the second one. So what you need to do in these kind of problems, take the LHS separately, take the RHS separately, and at the end you prove both of them are equal. This is the procedure. This is what you need to do. Fair enough? Let's do the first one now. So here, for the first one, we'll start with the LHS. Alright? That is, we are going to do A plus B first. Then after that, we'll do the whole transpose. Okay? Now, A plus B. Basically, we have to do this plus this, isn't it? Minus 1 plus minus 4, minus 5, then 3, minus 2, then 6, then 9, 9, minus 1, 4, 2. This transpose, correct? Or you can say dash. Both of them are the same anyway. So when we do this one, the row becomes the column, column becomes the row, right? So we can write this as minus 5, 6, minus 1, 3, 9, 4, minus 2, 9, 2. See, this is what we have for A plus B whole dash. Now what we'll do the RHS part. That is, we need to do A dash plus B dash. Right? So first we'll do A dash. A dash is going to be minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. This is A dash plus, now B dash. B dash is going to be minus 4, 1, 1, right? 1, 2, 3, minus 5, 0, 1. Alright, now let's add both of them. Minus 1 plus minus 4, minus 5. 5 plus 1, 6. Then minus 1. Then 3, 9, 4. Then minus 2, 9, 2. See, if you look at it, LHS is equal to RHS. That's very, very simple. And this is exactly what is required from the first one. And we proved the first one, this one. You can also think of it more like a property where A plus B whole transpose is always A transpose plus B transpose. Similarly, we'll do the second one. See the second sub question. Let's do the same method what we did for the first one. That is, do LHS separately, RHS separately, and show that both of them are equal. So for A minus B whole transpose, A minus B, first we'll do the LHS. That's A minus B whole transpose. Alright. 1 minus of minus 4. That's basically 1 plus minus 1 plus 4. Minus 1 plus 4 is 3. Then we have 1. Then we have 8. Then we have 4. Then 5, 9. Minus 3. Minus 2, 0. This is A minus B. Transpose of this one. So we need to do dash. So when you transpose, we're going to get 3, 4, minus 3, 1, 5, minus 2, 8, 9, 0. So LHS is nothing but A minus B whole transpose like what we have here. Now after this, we'll do the RHS. So for RHS, A dash minus B dash, correct? First we'll do A dash, minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. This is A dash minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. Correct? Subtract minus 1 So you're going to get 3, 5 minus 1, 4, minus 3, 1, then 5, minus 2, then 8, 9, 0. See, this is basically the proof. Again, this is also one of the properties, you can say, property or a law or a theorem, you can call it however you want. But this is true for every sort of a matrix. Well and good. Now we'll do the second question. Look at the second question. Now in the first one, we did for we did for addition and subtraction, correct? So here we are going to do for multiplication. Now generally in your exam, final exam, these kind of problems will come for either 2 or 3 marks depending on how big the matrix is. So when I say how big it is, the order especially. Like if you look at a 3 cross 3 matrix and the same multiplication question is gonna come, that's generally for 5 marker. Alright, and these kind of problems can come for 2 or 3 marker depending on the level of difficulty of the problem. Okay, please make a note of this one. Now let's do this particular question. See here, you need to do AB whole transpose is B transpose into A transpose. Now multiplication. So the first part will do AB. So AB. Remember, this is a 3 cross 1. This is a 1 cross 3. So the result is going to be a 3 cross 3 matrix. Right? So AB is going to be, so 1 into minus 1. Correct? Minus 1, then 2, 1. 4, minus 8, minus 4, then minus 3, 6, 3. This is AB. Now transpose of this one, AB whole transpose. This is going to be minus 1, minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. This is AB whole transpose, correct? Now the RHS, that is B transpose into A transpose. Now B transpose is going to be, so let me write it here, B transpose minus 1 to 1, correct? A transpose is going to be 1 minus 4, 3. Again, it's a 3 cross 1, it's a 1 cross 3. So 3 cross 3 is what we are going to get. So now B transpose into A transpose. This is going to be first minus 1 into 1 minus 1. Minus 1 into minus 4 is 4, minus 3, then 2, minus 8, 6, 1, minus 4, 3. I hope all of you remember the matrix multiplication, right? In the first one, you have to be row. Second one, it has to be column, correct? If you remember, so we are going to do, this is row, this is column, correct? That's how we were doing it. And this is what we are going to get. But if you look at this one, see the LHS part, AB whole transpose, look at B transpose into A transpose, both are one in the same. So we can conclude saying that AB whole transpose is B transpose into A transpose. Alright, this is the proof. They might ask you to prove it generally, alright, or they can ask you with a matrix like what we have here. Fair enough? Now let's do the second subpart in the same thing. See, in the second part, what we have, again, AB we have to do. Remember, row, column, correct? So first AB is going to be 0 into 1, 0, 0, 0, because 0 into anything is 0, right? 1, 5, 7, because 1 into any number is the same number. Now, 2, 10, 14, correct? Transpose of this one, 0, 1, 2, 0, 5, 10, 0, 7, 14. Fair enough? Now the other part, that is first we'll do B transpose, which is going to give us 157. A transpose is going to be 012. Correct? So now we are doing B transpose into A transpose, which is nothing but here we have to do row column. Correct? 1 into 0, 0, 1, 2. Correct? 5 into 0 is 0, then 5, then 10, and 0, 7, 14. Again, we can directly say by looking at this one and this one, if you compare, if you look at it, we can say AB whole transpose is B transpose into A transpose. Suppose if they give you this particular question in your board exam, which is definitely you are going to have it. Okay, I'm telling you, you will have it. But then the point is, which question that changes? What type that can change? Like you can have a row matrix, column matrix like the one what we have here, or you can have a square matrix. The method is the same. All right. So remember to write the steps carefully and properly, and then you guys will get the answer. So in the next video, we'll look into the next concept.